Hello and welcome back to Introduction to Number Theory. In the previous video, we got acquainted with quadratic rationalities, and in this video, we will learn how quadratic irrationalities make friends with arithmetic operations. Well, for instance, if we take two quadratic irrationalities, which means we take two numbers, z1 and z2, that belong to the set z of square root of a, which is, may I remind you, the set of all real numbers that can be represented as integer plus integer multiplied by square root of a. So we take two z's from this set, z1 and z2, and then show that their sum, their difference, and their product also belong to this set, which will mean that this set is closed under these operations. Well, since z1 and z2 belong to this set, this means that both z1 and z2 can be represented as x plus y square root of a, where x and y that correspond to z1 have indices 1, and x and y that correspond to z2 have indices 2. Well, it's obvious, I suppose, that both sum and difference of z's are represented as integer plus integer multiplied by square root of a, because we can certainly make this parentheses. Well, product of z1 and z2 is a bit complicated, but just a bit. But let's take a look. z1 multiplied by z2 is, well, you see, x1 multiplied by x2 plus y1 multiplied by y2 multiplied by a, which is formed of the irrational parts of z1 and z2. When they'll multiply, they form just a. And the irrational part of the product of z1 and z2 is of the form integer multiplied by square root of a, and this integer is, as you can see, x1 multiplied by y2, they cross a bit, and plus y1 multiplied by x2. So we understand that z, as I said, z of the square root of a is closed under operations of sum, difference, and multiplication. It's obvious that 0 as a number and 1 as a number also belong to this set. Also, all of the standard properties of arithmetic operations, of course, hold, because we are within the set of real numbers. What does this mean? This means that we're dealing with a ring. Z of the square root of a is actually a ring. But what about the fourth arithmetic operation? What about the division? Well, we'll talk about division in our next video.